In this video, we're going to look at another important theorem you need to know for the AP test, and that is the intermediate value theorem. So before we talk about the intermediate value theorem, let's just quickly review continuity. So we have this definition for continuity. All right, a function is continuous at a value if all three of the following hold. The limit has to exist, the function value has to exist, and those two things have to be equal to each other. Right, so those are the three things that go into being continuous. But for this video, just remember continuity when you think about the graph, as long as I don't have to pick up my pencil or marker or stylus or whatever I'm doing, so I don't have to pick it up, it's continuous as soon as I start to doing things like drawing open circles or drawing asymptotes. That's where I'm not continuous anymore. All right, so what does the intermediate value theorem say? We have a continuous function, so it has to be continuous. If it's not continuous, you can't do the intermediate value theorem. All right, so we have the continuous function. If we have any number between f of a and f of b, there's some value, x value, where if I plug that into my function, I get c. All right, so we'll look at a picture in a second. But pretty much, if I have f of a down here, I don't know why I'm writing in the highlighter, f of a down here, and f of b up here, I have to hit everything in the middle. So pick any c in here, I have to hit that c at some point. But let's see why this is true. All right, so we have our graph. We have, let's just put a here. Let's put b here. Let's just say f of a is lower than f of b. It doesn't matter. F of a and f of b. All right. So right away, we know we have this point and this point on my graph. All right. I plug in a, I get f of a. Plug in b, I get f of b. And let's pick a random c. So I'll just kind of make a random mark there. All right, that's my c value. So I want to know, is my graph going to hit this y value c at some point? All right, the answer is yes, it has to, but why does it have to? Well, if I draw my continuous function, I can't lift up my pencil. And if I can't lift up my pencil, at some point, I want to get to that red dot in the top right. There's no way I can get there without eventually crossing that dotted line in this value here. Oops, if I can draw in a straight line. That value there is the z they were talking about. So because I can't lift up my pencil because it's a continuous function, I have to cross this c line to get to that red dot up there. And it wouldn't matter if f of a was on top and b was on bottom. Again, at some point, no matter what I do, I have to cross to get down there. And that would give me another value. All right, so that's the intermediate value theorem. All right, but the way you apply it is really what's important for the AP exam. All right, so here's a multiple choice question. They say we have this continuous function. It's really important they say it's continuous if you're using the intermediate value theorem. What is the fewest possible number of zeros of f on this interval? All right, let's kind of draw what they're telling us. All right, so we have these x values at -1, -2, 0, 1, 2, and 3. At -2, my function's -2. Oops. At -1, my function's 5. At 0, it's 2. At 1, it's -4. At 2, it's -1. At 3, it's 3. Right. By the intermediate value theorem, all right, I kind of have to just make my way from here up to here, from there down to there, from there down to there. Right, I can't lift up my pencil. What's the fewest number of zeros I could have? It would be 1, 2, 3. Because every single time I switch from a negative value to a positive value, I have to cross the x-axis. So positive to a negative crossed, negative to a positive crossed. That's the fewest numbers. I could have more, right? I could do something like this. I could have a lot more zeros, but I have to have those three. Every single time I switch from a negative to a positive, there's a zero in between. Positive to a negative, there's a zero. Negative to a positive, there's a zero. So that's what the intermediate value theorem tells us. I couldn't do this if it wasn't continuous because I could just jump up over those zeros. All right, so this would be a free response type question. The amount of money raised during a competing fundraising campaign. So this is part C. So in A, I was talking about a different one. It is modeled by this function where m of t is measured in blah, 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 blah. According to this model, is there a time t at which the amount of money raised is $10? Justify your answer. All right, so this is one of those ones that seems almost impossible when you first read it, but if you know, and we'll talk about more of this when we go over free response questions in detail, if you know you're going to use the intermediate value theorem, it's actually pretty simple. I don't care what the time is. If I wanted to find the exact time, it's a really hard problem, but I just want to know, is there a time? And what I'm going to do is I'm going to look at my starting and ending values, 0 and 2. I'm going to plug in 0 into my function. 240. 2 to the 0 minus 1, over 2 to the 0, 6. All right. And 2 to the 0 is 1, so this is 240 over times 0 over 37, but that's 0. So I put in 0, I get 0. When I put in 2, squared is 4. And I'm just going to use a calculator real quick to do that because I'm lazy. 240 times 3 is 720. 720 divided by 40 is 18. All right, so how is this helpful for anything that I'm doing? Well, because I start my y value at 0. My y values end at 18. By the intermediate value theorem, I have to hit everything in between, and 10 is in between. So if I was doing this, I would say, since m of t is continuous, and m of 0, goes 0, and m of 2 goes 2, there has to be a t such that, basically just restating everything, m of t equals 10 by the intermediate value theorem. My handwriting is getting worse and worse as the sentence goes on. All right, but here's the important parts of getting all the points for this if this was a free response. You have to say it's continuous. The intermediate value theorem doesn't have to say it's continuous. You just say the starting y value, oh, this should be an 18, I already got points off. The ending y value, and that your y value is in between those, and you have to say you're using the intermediate value theorem. All right, so all that together would give you full credit on that problem. All right, so quick summary, the function needs to be continuous for the intermediate value theorem to work. All right, so always make sure you're thinking about continuity when you think about the intermediate value theorem. All right, but the main idea is you hit every y value between your endpoint y values.